Hello students, this is our first video lecture on the statistics material. So we're going to start a new chapter and it's kind of change gears for a bit. Okay, so what we're going to talk about first today is types of data. So when we talk about data, data is any kind of information that we collect. So you might think of data in terms of like computer data or things like that, but data really just means information. Okay? And so when we talk about it as mathematicians, we like to divide data into different categories because it kind of tells us how we're going to work with it. Okay? So broadly speaking, the two main types of data that we talk about as mathematicians are qualitative data and quantitative data. Okay? So qualitative like quality, quantitative like quantity. Okay? So qualitative data is um, not numbers, anything but numbers. Quantitative data is numbers. Okay, and that's as simple as it is, and it really is that easy, right? We'll talk. There are maybe some small complications, but it's pretty simple to tell between qualitative and quantitative data. So if somebody asks you a question where the answer is not a number, they're looking for qualitative data, right? Like, what's your favorite sports team, right? So if somebody asks you that question, they're asking for a name, right? Not for a number. Whereas if somebody asked you, what's your age, right? They're looking for a numeric answer, right? Something that's actually quantitative, okay? It can get a little bit more complicated. So there are things that you'd have to think about for a little bit. For example, what's your birthday, right? So is that numeric information or non-numeric information? You might say, oh, well, um, my birthday is October 24th, right? 1980. Is that numeric information or non-numeric information? Most people would say that that's quantitative information, right? Because if you think about dates, they're arranged in a numeric order. Um, so you could probably um, argue kind of one way or another that that's qualitative or quantitative information, but most people would treat it as quantitative. If you think about it, my birthday is probably before yours, for example, and so things that you can arrange in order, numbers make sense for that. So that's quantitative information. Um, we can also think about collecting the same information and asking the question in a way that gets us qualitative or quantitative data. Okay, so let me give you an example of that. So if I asked you, how do you feel, right? That's a qualitative, I'm looking for qualitative data there, right? That's a qualitative question. How do you feel? You wouldn't say I feel 5 or something like that. But if I asked you on a scale of 1 to 10, with 10 being great, how do you feel? Right? Then 5 would be a legitimate answer, right? You say on a scale of 1 to 10, I feel 5, kind of in the middle between bad and great. Okay? So you can collect the same information in a qualitative way or in a quantitative way sometimes. Okay? It depends on exactly what kind of data you're collecting. Um, Even if you do collect qualitative data, a lot of times you can convert it into a quantitative data by calculating the number of different responses that matched something. Okay, so for example, if I asked, what's your favorite sports team? I could say 97 of the students responded with the Mustangs, right? Because we love the Stevenson Mustangs, right? And so you can take that number 97 and make that into your data that you work with. Okay, so sometimes you can count things up and then turn qualitative data into quantitative data. And that's what we usually do with it if we're working with it as mathematicians. So when you see us talking about qualitative data later in the chapter, generally we'll add up all the responses that will match something particular and say, okay, now we've got some quantitative data, something we can actually work with mathematically. Okay? So, since we're mainly focused in mathematics on quantitative data, working with numbers, we actually split that up into two different types of data. So there are two types of quantitative data. And so those two types are discrete. So this isn't spelled discrete like somebody who can keep a secret. This is Discrete, not EET. They're close words, but that's discrete. And then the other one is continuous. Okay? And so the difference between discrete and continuous data is kind of complicated, and mathematically it can be very complicated. And so I don't want to necessarily go into all the details, but I will give you kind of some rules of thumb, what are good enough for you to figure out whether something is discrete or continuous. Okay? So discrete tends to be not many different values. Another way of thinking of it is being like counts of things. Whereas continuous data means that there's lots of different values, different possible values. And one example of this is measurements. Okay? So let me just give you some quick examples of discrete and continuous, and then we'll talk about more kind of details of it. So like something that would be discrete, if I asked you, how many pets does your family have, right? The answer is probably going to be 0 or 1 or 2 or 3. Maybe if you've got a fish tank, it gets a little bit larger, right? But some number less than like 30, hopefully, probably, maybe not. But not a lot of different values. It's a count. How many pets do you have? Whereas continuous data, if I asked you, and obviously this is a very private question, but how much money do you have in your bank account? There's lots of different answers that you could give there, right? And so we think of that as being a measurement, how much money. Now, again, it is kind of a count, right? You're counting the number of dollars, but there's a lot of different possible values, okay? And so that makes a difference in how we have to deal with the data. We'll talk about this as we go on, but you'll see that it's much harder to kind of graph continuous data because there are so many different possible values than discrete data. Okay, so let me just give you a few examples of each of these. So I already gave you a couple. How many pets is a discrete example. How much money do you have? Is a continuous example. So what would be another good discrete example? How many movies have you watched? In the last week? Right? How many movies have you watched in the last week? Probably a small number, a count of things. Whereas, how tall are you? Right? This is a measurement. Lots of different possible values. Let's see. this is a good one because this is one that always trips people up when we kind of think about it. So how old are you? Generally, we think about this as being a continuous kind of problem. Okay? And so you might say, okay, well, there's only so many different ages that you could be. Um, but if you think about it, if you look at all people, everybody's in a range of, say, somewhere between 0 and 120 years. So that's a pretty large possible group of numbers, right? And so we usually will split people up into categories instead. Um, so the other thing to think about is there are actually more than just saying I'm 1 year old, I'm 2 years old, I'm 3 years old. And this is especially true when you get to little kids, right? So if you have, say, somebody's got a new baby and you ask them how old they are, they're not going to say, oh, they're 0 years old, right? If they're younger than 1 year old, right? They're going to say, oh, they're 2 months, they're 3 months, they're 4 months, whatever, however many months, or maybe even weeks, or 8 days, or something like that. And so this can take on a lot of values. You have to think about all the different possible values that it can be. Okay? And so we generally would think about that as being continuous data. Okay? So that's the difference between quantitative, continuous, and discrete. Other examples, so one good example of the same kind of data in two different forms. So grade points would be, so for example, if you get an A, you get 4 grade points. If you get a B, you get 3 grade points, right? That's discrete data. There's only so many different values, right? Whereas like your percentage on an exam, that's continuous data, right? Because there's, again, values between 0 and 100. There's a lot of different possible values. Whereas here, there's 4 points for an A, 3 points for a B, 3.75, I think, for an A minus. I don't remember. Anyway, only specific values and not too many of them. Okay? So that's the difference between qualitative and quantitative data, and then the difference between different types of quantitative data. Quantitative data, discrete data versus quantitative continuous data.